Okay, this is Physics Chapter 2, Problem 67, and it reads, when jumping, a flea reaches a takeoff speed of 1 meter per second over a distance of 0.50 millimeters. Part A, what is the flea's acceleration during the jump phase? And so to make things easier, we're going to start off by converting our 0.5 millimeters to meters. And there are 1,000 millimeters in a meter. So we get 5 times 10 to the negative 4 meters is our millimeter. Okay, so for part A, we're going to use the equation velocity final squared equals velocity initial squared plus 2a multiplied by the change in x. And so we're going to rearrange this equation to solve for a because we're trying to find the acceleration. So once we do that, our equation becomes a equals velocity final squared minus velocity initial squared over 2 multiplied by the change in x. So now we just need to plug in values for that. So our velocity final is 1.0 meters per second. We're going to square that minus 0 because our velocity initial is 0, and then multiplied by 2 and multiplied by our 5 times 10 to the negative 4 meters because that's our change in x. And when you do that, you get 1 times 10 to the 3 meters per second squared, or 1,000 meters per second squared. So that's our acceleration. And part B asks, how long does the acceleration phase last? And so for this one, we will be using the equation velocity final equals velocity initial plus the acceleration multiplied by the change in time. And we need to rearrange this equation to give us the change in time because that's what we're solving for. So once you do that, you get change in time equals change in velocity divided by acceleration. So once again, we now just need to plug in our values. So we get our change in velocity is once again 1 meter per second minus 0 because our initial is still 0. And then our acceleration we just found was 1,000 meters per second squared. And then we get 0.001 second, or we can convert that back to milliseconds, and we get 1 millisecond. That's how long the acceleration phase lasted. And part C says, if the flea jumps straight up, how high will it go? Ignore air resistance for this problem. In reality, air resistance plays a large role and the flea will not reach this height. So, for part C, we will be using the equation velocity final squared equals velocity initial squared plus 2a multiplied by the change in y. So we're using that same equation. And then this time we're solving it for the change in y. So once we rearrange our equation, we get velocity final squared minus velocity initial squared over 2a. And so we just need to plug in our values again after rearranging it. So we get 0 minus 1 squared over 2 multiplied by negative 9.81 meters per second squared. Because in this case, it's gravity acting on the flea and it's moving down, so gravity is in a negative direction. And then we get, and then on the other side of this, our y final, okay, so yeah. So for our change in y, it's y final minus y initial. So we're looking for y final, and our y initial is still 5 times 10 to the negative 4 meters. So it's y final minus that value. And then after you do that, you get y final equals 5.15 times 10 to the negative 2 meters, which is approximately 5.1 centimeters.